Good afternoon to one and all present here today. I, Hazarika, on behalf of the entire team of Conscientia 2018, welcome you all to the Talks and Lecture series. Since its conception, Conscientia, IIST's annual technical fest, has always tried to break the shackles of ignorance and undertake the daring adventure into the unknown. The Talks and Lecture series has always been an integral part of the fest, where our highly reputed and knowledgeable speakers dispense knowledge and inspire us not only to be better engineers or scientists, but also better individuals and a more resourceful and compassionate society. This year as well, we present to you speakers who should undoubtedly inspire you to be passionate and work hard, but above all, be curious. For our first talk, we have the pleasure of introducing to you Dr. Arun Surendran, the Principal and Strategic Director of Trinity College of Engineering, Trivandrum. Dr. Surendran did his B.Tech from Indian Institute of Technology, Bombay, and proceeded to do his MS and PhD from Texas A&M University, one of the most renowned universities of the world. Here, he was conferred with the EPRIDE Outstanding International Student Award, the highest accolade presented by the university to any international student. While on a visit to India in 2011, he was vested with the responsibility of running the Trinity College of Engineering. In his tenure as the principal and strategic director of the college has been successful in establishing an Innovation and Entrepreneurship Development Cell, or IEDC, which aims to foster the growth of innovation and entrepreneurship amongst the faculty and the students. Additionally, he serves as an operations advisor to Al-Agra, one of the largest construction conglomerates in the Middle East, and serves as one of the directors of the Bankers Training Center, operations director of Gallup Solutions, and chief mentor for Coin and Day Child Care Foundation. Dr. Surendran is the academic advisor to UST Global's Infinity Labs and Trivandrum Technology. He was chosen to deliver the Vikram Sarabhai Memorial Lecture in 2017 by the Space Engineers Association and is a regular keynote speaker for various organizations. Sir, it is an honor to have you amongst us today. Today's talk, Managing Innovation in the Fourth Industrial Revolution, focuses on the interesting history of innovations, how certain ecosystems fostered it, and what are some of the ways in which we can make ourselves more fit to the evolving age of continuous innovations. Without further ado, I now invite Dr. Surendran to deliver his lecture.
You want me here or?
Call a mic here.
Okay. Can you hear me without the mic? Oh, perfect. Then if you can sit to the front, we'll do away with the mic.
Yeah, that's fine.
This can pick up, right?
Yeah, this can.
Sound?
Yeah.
Okay.
Yeah.
Yes, front bench. Always make it front bench.
इधर ही करना तो मून को देखिए
Okay. Thank you for the wonderful introduction. And it's good to be back here. I used to teach as a guest faculty in the aerospace vehicle design course here at IIST in 2013 and 14. And then I was back as the quizmaster for Thanak 2015. It's great to be back here for Conscientia. So we'll keep this as interactive as possible, since this is a fairly intimate crowd. And it's going to be a straightforward keynote lecture because it's 2:40. Nobody wants to listen to a lecture at this hour, and unless somebody wants to deliver a lecture at this hour. Labs are okay, the afternoon lectures are not certainly long. So let's get started. I have been talking about this topic for almost a year now, because this is more of a challenge for me. It's not that I know anything about this. It's precisely because I don't know. And I'm trying to get as many ideas as possible from as many minds around. How can we manage innovation? This fourth industrial revolution. Okay? So we'll set the context and then probably discuss together how innovation can be managed. Because it's a national challenge and I'm very much aware that I'm talking to the brightest minds of India, as has been repeatedly told. Even if you agree or disagree, that's the way it is, okay? Okay, industrial revolutions. No, it's fine. But you can hear, right? Yeah. And it will help me finish faster. Not having it right. So industrial revolutions 1, 2, 3. Okay. Everybody has heard of the first industrial revolution, right? Where was it? Britain, Great Britain, right? With Manchester. I'm not using a mic, so to the front would be better. And what was the main characteristic? What product was manufactured? Steam engine was the source of power. Source of power was steam. And what was the most important transport medium? Rail track, right? And the energy, steam, that communication, coal was used, communication, telephone hadn't come yet, telegraph was around. And then came the second industrial revolution, where we switched the power to something else. Electricity came and petrol, right? And mode of transportation switched to the car, automobiles, right? And communication switched to telephone came. Third industrial revolution happened. These are all vague terms to understand, right? Somebody abstractly defines industrial revolution 1, 2, 3. Okay, fine, 1, 2, 3. So the third one they say is the digital age, 1960s, DARPA set up the internet and everything became, information became the primary thing. So we got into the third industrial revolution. What's the fourth? AI. Yeah, everybody is talking about fourth industrial revolution, but this is the man who called it. He said we are now in the fourth industrial revolution. Therefore, we all are. Who is he? Not seen him, not heard him. Do you have? If you have smartphones, please feel free to search along when I'm speaking. Okay. Klaus Schwab of World Economic Council. Schwab said we are in the fourth industrial revolution now, and there are certain characteristics that define it. And after that, so many people have already been saying we are in the fifth industrial revolution. Now it's a number game. Who calls the next one before it happens? So let's stick with Schwab. He's German, economist. I think also physicists, I'm not very sure. And many Americans who always these being contact forever. So, fourth industrial revolution, what are the characteristics? Artificial intelligence first. Yes. Big data, data analytics, then robotics, yes. What else? Can you sit in the front? I'm not using a mic. Yes. Wireless blockchain. Somebody brought up blockchain. Yes.
Internet of Things.
IoT, Internet of Things. And so on. So these are innovations that are happening. The way technology is changing as we speak, right? And we are talking about how to manage these things. Automation and IoT. Right? IoT is Internet of Things. That's a smart plug. That's from our college, from Trinity College. That's one of our innovations that's being built in the lab and supplied to students and faculty who need it. So basically, there's an Arduino, and then you have a GSM module. So you can control it anywhere using an Android app. Then automation. Everything gets automated. What's one of the big labor market fallout of automation? What's happening? Unemployment is rising. We are a country that benefited hugely from BPO, business process outsourcing. Now something else is happening. Jobs are getting reshored. They're going back to the countries from where they came because we are stuck with smart factories, which don't need a single person, right? You place an order, smart manufacturing happens, smart labeling happens, packing happens, and the drone will bring it to your doorstep. The entire human being is eliminated from the chain. GE has a smart factory even in Bangalore. So that has affected job market. So what jobs will be trained for? That's the second part of managing. Then 3D printing, yes, modern manufacturing. What's the difference between additive manufacturing and subtractive manufacturing? Right? Subtractive is? Okay, so how was manufacturing being done all over the world till now? Subtractive, right? Carpenter and Michelangelo did the same thing. Take a big block, start subtracting. You'll get the stuff you need. What's the biggest problem? You all had lathe work in first year? Ah, yes, so you know the problem. Yes, and the moment you lost control of one side, finished. You have to replace the entire block. With additive manufacturing, keep on adding. Even if you add a little bit more, it doesn't matter. You can always shave it off, right? See, this there is a underwater unmanned vehicle, UUV, that was manufactured in our college. This was a final year mechanical engineering project. So there is a FabX 3D printer, if you can notice. We used it to make all the propellers. Right? This thing was meant to go underwater. It had a very powerful video camera in the front and a grabber. So in case there was any obstruction, it was supposed to grab those things and remove the obstruction and so on. The problem was we wanted this to be lightweight, like 5.5 kilos. And that's a foam structure, the basic structure, on a CNC machine. But then it would need, as all aerospace engineers would know, very, very high twist propellers. Because we wanted the propellers to be small. And they needed very high twist to take this thing down and bring it back up. And if you try manufacturing that with subtractive manufacturing, it could take you ages with metal to get that kind of a twist. This took us to those student teams, the mechanical engineering boys. It took them 1 day, 6 propellers. FabX machine took 1.5 hours per propeller. And the added advantage was all of them are perfectly balanced replicas. If we go for conventional manufacturing, even if one of them is slightly imbalanced, the whole vehicle won't stay. So we got that done. And then FabX machine, any idea how much it costs? That 3D printer, that particular model that you see. 50? 50,000. Anybody else? Any other guess? Huh? What? Somebody said crores. Nirav Modi in the making. Quoting in crores. Yes? Still further down than 50,000.
32,000.
Yeah, it's 30,000 when we bought it after bargaining. 30,000. See, so 30,000 rupee machine takes 1 day to give you something which, if you run a mechanical engineering workshop with technicians and material, 1 month it will cost you around 1.5 lakhs to pay 5 technicians to stick around the electricity, the rate, and everything. So this is precisely how manufacturing is going to change with 3D printing. Now we have other materials also being used. This is classic PLA machine. It's not very suited because we already lost one of the fins of the back propeller. So we broke the other one as well to keep it perfectly balanced. It was going to doesn't matter. Now we figured 2 would have been enough. 3 was an over. Smart energy, where is this? Identify this place. Somebody said China. Kochi International Airport, which is the world's completely solar-powered airport. And now, today I read there is a distinction that the Energy Management Center in Trivandrum is being quoted by United Nations as a surplus energy building, green building, for the first time. So we have some classic examples. Now, from steam to petrol, electricity, renewable energy, now we have come to smart grid control, right? Whatever we need to manufacture the energy as is needed, we can do that. Tesla electric car, everybody saw the new Porsche electric model. It was out yesterday. Porsche's new electric car is very classic, completely porcelain by its design. So electric cars are coming in a big way. And this is another characteristic: collaborative commerce. A group of people coming together and managing an economy on a very small scale. You must have heard of all the organic farming communities. Similarly, we can have manufacturing communities, aerospace engineering communities, which can take up subcontract stuff from you and start doing stuff. This used to be how things used to work before the Industrial Revolution. There would be huge, fiefdoms, and serfs would be given pieces of the land which they will manage, and then there will be a tax paid to the king or the noble in that area. But collaborative commerce, if Some area they'll be grazing allowed, some area will already farming, but you will collaborate how to manage. Now we can do this because of IoT, because of instant communication, in a much better way, how efficiently each person's talent can be used. Now, where are we aiming? This is a personal opinion. Ultimately, where is all innovation supposed to take us? Why do we keep making things, improving designs? We're doing better and better, using less energy. There is this, I think there is an urge to get to biological efficiency. Can we be as efficient as life when it comes to using it? That took almost 4 billion years to get to the level of perfection at which it manages energy and tasks. Those are two of my favorite examples from efficiency. What's on the frying pan? Balance. Good food. High protein, interval fat. Foods. Insect diet. There is a factory in India that makes crickets now. We love cricket, but now we love the other cricket as well. High protein, very crunchy, good snack. Good break. New age, good Now, the reason I mentioned that is last year at our international conference in college, Dr. Sudesh had come from University Saints, Malaysia, and he was into bioplastics research, manufacturing of bioplastics. So they used the kelp of the palm tree, which is then chemically processed, and then they had this entire huge chemical process that involves centrifuges and warming and cooling and things like that, that would finally lead to bioplastic. He also found that if they fed this thing to worms, grub, they will excrete pure bioplastic. Very high efficiency. Okay? That kind of efficiency. So they found that's good. It's a factory, biofactory that manufactures bioplastic. So we are aiming for that kind of an efficiency. Anybody knows the other animal? Very famous. For the octopus. Right? Octopi are very fascinating aquatic creatures. They don't have a central brain. They're clever. They are distributed intelligence. They can fit through a very small hole and come out. They can change their shape in any way. But do watch YouTube videos that show you octopus hunting. Right? There are very fascinating videos where the crabs are totally stuck watching this psychedelic display of lights and colors. This thing just goes dance in front of it, and all the lights and colors are running through the body. The other guy is stunned, and then it's finished. So that's entertainment value. But even when an octopus is sleeping, you can see these electrical pulses running all around the body. Intrinsic neural activity. And kind of a distributed intelligence where each tentacle has its own intelligence. Touch, feel, decision is made there. It's not like it asks the central authority, is it good to eat or not? Yeah, I can make the decision here itself. So that kind of a distributed intelligence and biological efficiency is what we are looking for. How do you define innovation? Well, that's, for me, it's the straightforward definition. There should be a better way to do it. The reason that's a bracket is because a lot of things get attributed to medicine. I might not have said this. Somebody put it up and thought, oh, if I say Arun Surendran, nobody will listen. So Edison has Edison said, I see quotes picture, but this is how much you can trust stuff that comes off the internet. Always run a search. It's a pretty good definition, right? Can we improve upon it? Innovate. There should be a better definition for innovation. We should think about it, right? I am seeking a matrix. I want a matrix. See, my problem is I am trying to be a manager of innovations. So I have students like you. I have faculty who come around and say, I have this fantastic idea, this new innovation, which I would like to try. Now, how do you grade that thing? How do you decide this is where the money should be put in? This is where we'll go spend time. This is where maybe the best brains can go and work on. Can we have some parameters? Is there a matrix into which we can feed this thing, get something out? So I have been going around asking wherever I can we come up with a matrix like this? Can we give some parameters? So last time I spoke at the Institution of Engineers, they said for creativity they have developed some parameters. How to judge creativity. Now we are looking for innovation. Is there a way to judge one innovation as better than some? Now, this is the most confusing slide, but my favorite. First up there is a jigsaw puzzle, right? William Gibson. How many of you have heard of William Gibson? The writer, neuromancer, novelist, cyberpunk genre, right? The future is already here, but it's just not evenly distributed. Some places are already ahead in future than the others. So that's one way of looking at innovation. It has happened here and there, here and there. We are all trying to fit the pieces together from different parts of the world, from different times, different centuries, and so on. One way of looking. The other picture there is Aymara tribe in the Amazon. These are fascinating tribes, and there's a book called "The Numbers and the Making of Us" by Canada, about mathematics and how much of mathematics is inherent, genetic, and how much of it is culturally acquired. So they have done some very fascinating research on newborn babies, just few days old, checking if they can identify numbers. So now we know that 1 and 2 we can when we are just born. After that, we are just able to distinguish between big group and small group. There are no other numbers. Rest is all culturally acquired. Now, this particular tribe is enumerate. There are no concept of numbers. It's very difficult to teach them to count. They can only talk about many, few, bigger, lower, and so on. And the other fascinating thing is the way they look at time. For them, past is in front, future is behind. For us, we are all marching into the future as if we know for sure where the future is, right? And we'll put things behind us. If it's in past, we'll throw it away. But I find this tribe very fascinating because what they're saying is true. It's only about past that we have a very clear idea. This has happened. And I don't know, the future is sneaking up on me from behind. I have no idea. I have no eyes there. I have eyes on my past. So they look at it like that. Now I'm thinking, can we look at innovation like that? Innovation has happened here and there and here. We are trying to put it together and see in which direction the world is going to move. And that there at the bottom are two of the famous paintings. You know the painter? No, not Van Gogh. It suddenly sounds like a quiz program, where the first guest is always Vincent Van Gogh. No. Salvador Dali. Dali's 1932 painting is on the right. It's called The Persistence of Memory. It's about hard and soft things in the fluidity of time. And the left, he painted it in 1952. It's called Disintegration of Persistence of Memory. It's a fascinating look at how things are analog on the left, and then there is a bit of digitization, discreteness coming up, and these underneath patterns that are being created. So, can innovation be looked at like this? How do ideas come from? Fresh ideas, new ideas. Russell Ackoff is a management guru. He said managers who don't know how to measure what they want settle for wanting what they can measure. This is very true, right? Should we read that again? Managers who don't know how to measure what they want settle for wanting what they can measure. How do you measure somebody if somebody is a very good aerospace engineer? We're a very good aerospace engineering student. I want to measure if somebody is a very good aerospace engineering student.
So you want to measure in which domain, as a student or as an engineer?
Oh, okay, as an engineering student, new domain in which you fit. How do we measure? Right? We have no idea. We have to think about how this measurement can be done. But what can I measure?
How differently can impact a problem?
Yes, I can put an exam to you and give you marks. And that measurement I'm fascinated with. And I'm going to equate that with how good an engineer you are. This may not be true. So if I cannot find a good, true measure of innovation, I will end up measuring how many hours does he spend in the lab, how much money are we going to invest. These are things I can measure. So I'll be very happy measuring such things. How much funding does he bring? Oh, that's a good innovation. Oh, he's brought in a lot of funds. So think how many people are in his team. Ackoff is a fascinating guy because he has made very interesting statements like the only people who have benefited from the education system is teachers. Right? I agree with him. 100%. He said the only people benefiting from classroom teaching is teachers. Students are not being benefited. We'll come to that. Now, this is what I'm looking for, scaffolding, or matrix and scaffolding. Because the moment we say frame, then it becomes again closed. Something that we can build up and use, and innovation we fit in, and look around it and find out the best thing. There are three criteria I can think of. One is straightforward, the financial rewards, right? Which is how it's so much easier to measure. Okay, does this product have a market, right? If you put it in, is it profitable? Can the company grow big? Can it become Tesla, Google? Great, good innovation, done. But there should be fundamentally, at least in India, two other aspects. One, is there a social impact? Will it take away jobs? Is it going to give jobs? How many jobs are going to be created? That should be one criteria. And thirdly, environment, right? Nobody says automobiles are a very great idea now, or drilling for petroleum, but they made perfect financial sense at the time, that innovation. Lead in petrol was a great innovation when it happened, now we are regretting it. So these three criteria I know, but I'm looking for more. And this is where we should change, right? How can we reorient education to bring in more innovation? That's a very fascinating book, The End of Average by Todd Ross. He's from Harvard Department of Education. Had a very tough life because he had to go through the conventional exam system in which he was no good. And then finally he figured out everybody doesn't have to take the exam at the end of the semester. Some of us are very slow, we'll take it at the end of the year. Slowly clear and go ahead. And then finally he made a career. Now here is the beauty of this. Aeroplanes, warplanes, used to crash a lot initially in the US. They had no idea why this was happening. Very competent pilots, all very well tested, but somehow planes were getting lost. And then they figured out that the cockpits were all made for the average US Air Force pilots. Who is the average US Air Force pilot? How do you find him or her? They take the height of all the US Air Force pilots divided by the number of pilots. That's the average US Air Force pilot's height. So average US Air Force pilots arm length, leg length, and so on. Such an individual doesn't exist. So when you sit on such a cockpit, it would be difficult for it to reach this, your head might hit. And in times of panic, obviously you are not able to reach into controls. And they fixed it by doing what? Which all of us now use in our cars. Yeah, the adjustable seat. Why don't we do this for our education system? Where is the adjustable seat of the education system? We are still trying to fit everything for the average student of IIST should be able to understand this. That student doesn't exist. That student simply is not allowed anywhere. So we need adjustable. We need from static to a dynamic understanding of knowledge. In India, we consider all textbooks to be holy books. Don't ask anything outside it, that's it. Don't try to venture outside it, scope of syllabus or scope, and so on. Second, this is a fascinating idea. I think our education system has borrowed from agriculture, farming. It's basically all writing, civilization, everything came at the end of agriculture, which is just 10,000 years old. So it makes sense that we treat students like we treat domesticated plants. We seat you all in rows, right? We plant you very nicely. And then one by one, the faculty will come, put fertilizer, pour water, whatever it is that can make you grow, help you grow. And then at the end of 4 months, we say harvest time has come. Let's harvest and see. And we'll declare half of you are good, half of you are not good. Some will stop harvest and so on. This is the farming model. It's only 10,000 years old. But look at the other model, which helps a company like Facebook or Instagram flourish. For 550,000 years, we were hunter-gatherers. We love hunting and gathering. It's in our blood, more than fun. We will hunt profile pictures forever. We will gather friends wherever possible. Right? How many friends do people have? More than they can manage. Right? Okay. And imagine what big change comes the moment you guys are given a project and asked to hunt and gather for information. Go find out. See if this can be done. Immediately. There is much more energy than sitting in rows and being told what's to be done. So can we switch to a mode where we are more hunter-gatherer, hunters for innovation, doing that? So again, I used cultivated innovation sense, so that you keep moving around, acquiring this particular sense of how to do things better. How can exams change? Can we customize all the exams? Can we give you exams in your mobile phone with face tracking so that I know you are sitting there and writing it without moving? Can it be customized? See, 7 hours after waking up, nobody is in a good mood. We all have a lull in energy. Right? I am presuming all of you woke up by around 7 o'clock today. So this is really pointless to be sitting in the lecture and worse to be writing an exam. But what happens if this is your most important exam in life? Get scheduled like that. We are missing out on talent and innovation like that. Can we change this? We have all the technology now in place. We should think seriously about it. Some of the great innovation stories to inspire for Mahatma Gandhi, great social innovation. Everybody was fighting for independence, as literally fighting. And then somebody comes along and says, non-cooperation, non-violence. You beat me up, does it matter? I'll stick around and stick to my message. Big, huge innovation that then went on to be copied elsewhere for the scholars. Anybody knows what the other book is? It's a page from a very famous book that engineers want to read at some point. It's from 850 AD. 850 AD it was written. It's called Book of Ingenious Devices, a book of tricks. It's by 3 brothers from Persia called Banu Musa. Take a look at it. It has a lot of interesting tricks, mechanical, not electrical at that time. So mostly creating devices that are ingenious, and always it's such play and curiosity and playfulness that leads to very good innovation. And that's something that's fast disappearing from all the institutions that are supposed to get. Anybody knows that other building? The E-shaped building, the one in the front. That's one of the most famous buildings of innovation. It's called building number 20 in MIT. Book of Ingenious Devices or Book of Tricks. Banu Musa, 850 AD. Right? This is building number 20. All of us will be familiar with Bose, Amar Bose sound system. Bose used to work in that building. That single building had 7 or 8 Nobel laureates at one time. The radiation lab of United States led to all sorts of innovations. Noam Chomsky used to work there, linguistic lab. How did that one building become a hotbed of innovation? Because it didn't have much of a structure. You would always bump into somebody who is from a totally different department, have a conversation. Right? You could totally restructure it, pull down walls, put in an electric connection here. Such kind of freedom in an environment that fosters innovation was there. And they tried to replicate it, I think, in the Cupertino Apple headquarters. Initially, the bathrooms were all supposed to be centrally located so that everybody would come in there and at least have a conversation. But it's not really good when you have pregnant women and handicapped people in the building. You have centrally located. But people are trying to bring people from various fields together. It's the exchange of ideas that leads to fertile innovation. Everybody knows what Jugaad is, right? Yes, especially at time of fest. We know how much of Jugaad goes on behind the scenes, so that we need to just get things done. But that cannot take you to a level of quality of very sustainable innovation. So Jugaad can be a starting point, but Jugaad happens simply because there are deadlines, which we need to fix, and then we can go from there. The other picture there of pharmaceutical companies is just so that I want to discuss Eroom's law. The order of Moore's law. Like what Moore's law? Not Moore's law, Moore's law, yeah. Yes, number of transistors we can squeeze into a chip, therefore computational power will double. 2 years, right? This is the reverse of that, Eroom's law. Like Moore's has been reversed, EROOM law, and it's related to pharmaceutical companies. It says the cost of developing a new medicine will roughly double every 9 years because of all the regulations and tests and things which are absolutely required, but that kills innovation in a very big way. So we have to guard against industries going in this direction. Now, a couple of pictures from the college and a couple of pictures which might be familiar. This is about scaling. Once you have innovated, how do you take it to a large scale? Right? The gentleman there who is showing his innovations here, he is a bus conductor in KSRTC, Kerala State Route Transport. He travels the Calicut route from Trivandrum. And his home was on top of a radio repair shop. His childhood was spent mostly in the repair shop. This man is with electronics. He has a Li-Fi device. He has perfected, from my mobile phone, we had streamed using lights, music to the speakers, using his device. And he comes with all sorts of static electricity detector, safety alarm for linemen when they climb up on posts. Man innovates a lot. Do we have a system to support such people? There are dime a dozen available in India for doing jugaad stuff, but very cool stuff. But we need to bring them into the mainstream and help them scale these innovations so that they become useful for all of us. Right? The second guy there, you might have seen him here in IIST. He used to come here as well. Niranjan Kumar, the guy who was sitting down near the vehicle. Niranjan Kumar, again, another serial innovator, always bubbling with ideas. And this is precisely where we need to think about how can we manage all these innovations coming to us at a rapid speed. And he doesn't fit the image of an automobile engineer. Right? Because he'll be wearing a white dhoti, t-shirt, he has that beard, looks more like a Swami than an engineer. So when he comes around to campus, students are fascinated that this man can just like that talk about BMW and the ball bearing size and things like that. So we need sort of an image correction there and then go on to maritime side. There again, Abdul Kalam becomes Sarabhai's scaling model, right? 1956. Nobody was thinking about space heating. Somebody thought, we should go. And the other guy there, Narlikar, very famous, the American equivalent, you would call it. 1960s, he sent out a memo saying, we need to build an intergalactic computer network. So that's the scale in which we can imagine stuff. We should. That's the only way we can scale up for innovation. And how do we go from projects to products? This is something that really bothers me. Students will come around, they just want to finish a project and go. Submit the report, do a presentation, that's it. Things never become products. That there you see is one of our college products. It's the breath analyzer that's being used by the Kerala Police Department. So we get a lot of flack from the alcoholics in the city, right? We supply those to them, but it had to change because we had to get feedback, continuous feedback from the policemen who were using this. First model was bulky, it had a long LED display. They wanted it to be changed to an OLED so that it would be kept in the pocket. They didn't want a buzz or alarm some of the times. It had to have much more clarity in calibration. Can you imagine trying to calibrate a breath analyzer in a college? How do you calibrate a breath analyzer? Yes? Any idea? There is no average drunk. I was asked this question. How do I know? Maybe I'm less drunk. Is it very precise when it detects the breath? Luckily, though we had many volunteers who came forward to help with the calibration process for many days, we got a full calibrated chart from US. There, of course, I think it was done with great work by many champion students in some university. I remember we used to have a road safety department, transport department in Texas A&M. We used to go to the runway where they would make the new sign posts, road signs. And one of the criteria was they wanted to know if drunk drivers can still recognize the signs. So it was good research. So you go there on Friday, they'll feed you the necessary material, and then they'll put you in a car and ask you to drive. And at the end of the drive, they'll ask you, did you notice that road sign? No, okay, fine. We need to add some more colors. So something similar. So see here, again, the demands were different. Some policemen said, see, we allow few people to slide if they are under the limit. So your device needs to tell us they're under the limit. And some need to be immediately told over the limit. Now the biggest struggle is there an equivalent for other substances? Drunk driving, even human beings with a very good nose can detect. What about other substances? So we are thinking of innovations possible with the pupil dilation and things like that. Come up with there's a big market for it, and it's a social necessity as well. But how do you always convert from a project to a product? Will some people really use it? Will it benefit? That calls for continuous feedback. So one way we managed to do this in our college is that I asked the faculty themselves to become entrepreneurs, to run companies, be engineers, okay? Run the engineering college like a medical college. Nobody thinks of medical college as a college. They think of medical college as a hospital. All of us look at it as a hospital. Because the best doctors are there, the surgeons, they do the surgery, they're practicing the thing, they're also teaching. Similarly, how many of you with your vehicle broken down will ever bring it to an engineering college? Best engineers should be there. So we wanted that model. So now we have 12 companies, core engineering companies, which are run by faculty members. So we are very keen on products because these are businesses and they need to run, develop stuff, get feedback. And what are some of the warnings that we need to keep in mind? One of the things about stressing too much of innovation on students is that true intuitive expertise comes with prolonged experience and with good feedback that may not be always available in a classroom setting or within 4 years of your BTech. So you should try to get somebody more experienced as a mentor or as your team member so that they'll have some kind of intuition about whether something is going to work or not going to work. Any idea who the other guy is? The very famous astronomer. Pluto is named after him. His name is not Pluto, but the name Pluto was given in honor of him. PL, those are his first letters. No, P and L are the first letters of his name. Percival Lowell Observatory. Right? Lowell had the most powerful telescopes of his time. But he never allowed anybody else to come and look at it. He wanted to get all the research done by himself. The problem was, any heavenly body Lowell looked at, he would detect canals, very fine shapes and squiggles and structures, which only he could find. Nobody else looking through telescopes anywhere. But then he said, yes, your machines are all inferior. I have very superior machine. Now, after his death, we figured out, how many of you have noticed squiggles when you look at the lamp? You know, things floating in space before you. Those are the problems with your eyes, right? Those are the patterns that are there in your eyes. These were the patterns in Lowell's eyes. And he was seeing them in all the heavenly bodies, looking through that very tiny aperture of his telescope. This could happen. If I have a set of ideas about what constitutes innovation, what constitutes successful design, I will see it anywhere. I'll see only that, not anything else that comes up. Last two figures, very easy to identify. Steve Jobs is there because he wasn't a great engineer, but a great manager of innovation, right? And he was reasonably quick to correct his mistakes as well. Initially, he didn't allow third-party apps to be written for iPhone. That would have been a big mistake. He said, only we'll write the apps and we'll keep it. But then he saw the popular demand and changed. He didn't design the iPhone, but he had the sense enough to say, touchscreen will change everything. If you read Scott Galloway's book called 4, it talks in detail about how the first touchscreen model was shown to him. It was projected from a projector. It was displayed, it contained white paper or physics was projected. To see that and think, okay, this could be the future on a phone, that takes a lot of intuition and experience. So a great manager of innovation need not be a great innovator, much less a good engineer. Somebody who has a feel for those. The other guy, Gary Kasparov. He has a book out called Deep Thinking. Last year it came, which talks about the machine that defeated him, Deep Blue. He says a little bit of iffy things about Deep Blue because IBM never owned up to Deep Blue after that. They quickly disassembled it, sent it away. Watson, their next machine is still available. It does some kind of artificial intelligence work, but Deep Blue was taken away. He talks very interesting stuff about deep thinking, the need for sitting around with an idea, analyzing it, and how education can help us do that. Aero people, Scott Kelly, you heard of Scott Kelly, right? Man who spent the most amount of time in space, 365 days, like full year. He has an amazing autobiography out now called Endurance. It has some deep inspiration for engineering students when it comes to studying calculus as well. He talks about the turning point in his life before a calculus test. He gives a very intriguing example of the difference in education system between USA and Russia. He says, if for US, the class is about how to mail a parcel, right? The teacher will come to the class with a cardboard box, which is supposed to be the parcel. We'll all put things in there. The students will learn to close the cardboard box, put the sellotape, address it to somebody. We'll take it to the post office and we'll mail it. The lesson on how to mail a parcel is complete. Education is done in that department. The Russian education system, he says, we will first take you to the pine valley, from which the pine trees will lead to the cardboard. That will create the cardboard box. But by the time we have reached till felling the pine tree, the time is over, semester is over. So the exam will be about pine trees. But the degree will be on how to mail a parcel. I think we are very close to the Russian system compared to the American system. Theoretically, our knowledge is sound, fundamental, historical based, but practical knowledge still needs individual effort from each and everyone. That's my last slide. I borrowed that particular idea of, not idea, example of innovation from Sanjeev Dhurandhar, who is the head of the Center for Trinity here in University of Kerala. He said, Wound is a great innovation. Very simple. Right? If you want a pocket, you can make a pocket. If you don't want a pocket, there is no pocket. There is no zip. There is no fixed size. Even if you gain a few inches, it doesn't matter. If you lose a few inches, it doesn't matter. It still fits. If you don't have a blanket, it doesn't matter. The wound will come in handy. If you don't bring a bed sheet, it doesn't matter. The wound can double as a bed sheet. Right? If it rains, you can pull up the wound. If it's not raining, you can show respect, you can show disrespect. Whatever it is that you want, the simple wound will help. Let's look for simple innovations that have very deep impact. Thank you very much.
Thank you, sir, for that wonderful lecture. I would request students for asking questions to sir, in case anyone has anything.
Yes.
In that case, that project to product that you told us, there's a big problem in that concept. What I feel is, like, suppose we are given a project to complete it, we majorly focus on how to achieve that thing rather than learning. Learning lacks at that point. So maybe that stable innovation that you told, that is the main problem. Like, to persist that stable, to have that stable innovation in us, we should be having a good fundamental.
Yes.
But if you go for a direct product establishment or product development, then somewhere we need to keep our focus from focusing on the fundamentals and have to have some that jugaad kind of thing. Like, suppose there is one software in our case, aerospace. So there is a simulation software. Suppose there is two ways to do a simulation. Either you write your own code, either you directly go for the software.
Right.
If you go for directly software, you will get good results. But if you write your own code, you won't be able to get the result.
Yeah.
So the timeline frame is finished. Yes. So how will you justify that thing? Like,
no. See, I wasn't saying don't do projects. Projects are absolutely essential, and I think projects will help you learn much more than a conventional lesson. That's also there. Suppose we started all the classes by giving a task. Let's say this is the task we have to solve, and then we are introduced to the tools, the fundamental tools, the mathematical tools, the conceptual tools, and then we try to attack that task. We solve it. So we gain an idea of how exactly the concept is. Now we go and do a project, which we will take our own sweet time, learn the fundamentals and do it. Now at that stage, the innovation part we have finished. My idea is, from there, those who are interested, innovators and entrepreneurs, they need to go one step ahead, where it becomes a product. And so many good projects are languishing in many labs because we never took it to the next product level, where it could really benefit. Otherwise, the students and the faculty are the only beneficiaries of doing this. The society doesn't get any big benefit from fundamental ideas, beautiful ideas that you had. There it needs product. We can't go and tell them, hello, you need MATLAB to do this, then your face analysis will happen. We need to take it to that level. So that needs an entrepreneur and innovation. That's all. Projects are a must. But then some of them are so good they deserve to become products. Yes. Thank you.
Actually, I have a fundamental question of what is considered to be innovation in India versus that of the global. So, for example, in our labs, we are having these soldering irons imported from Germany at a cost of some 16,000 rupees. Now, instead of focusing on smart something and IoT and because that's what everyone wants to focus on, and nobody wants to actually develop that kind of technology which is high quality. So how do we address it? Is it not considered innovation because some other country has it?
No, not really. See, one of my favorite exercises in the college is when the first new batch of students come in, we project a big collage of faces. And there are 100 film actors and actresses are in that picture. And I ask them to identify. And they get 100 out of 100. Malayalam, Tamil, Hindi, Telugu, they know only 100. Then we put up a collage with 25 cricketers. Majority get all the 25, some get 24, 20. Maybe they don't know a new South African. And then I asked them to tell me 5 engineers in India. 5. Sridhar, everybody says. And then after that, it's a big struggle. We go back to Abdul Kalam. So what? Because the role models are a problem. So similarly, when you are talking about entrepreneurs, immediately it is Bill Gates, Zuckerberg, right? Sergey Brin, Larry Page. The Indian examples are missing. And that's why we are taking for granted that, okay, soldering iron and all should come from Germany. Here we'll think about big ideas or very social ideas for water purification and things like that. The big gap in the middle, that's what needs to be addressed. You're absolutely right. See, there is a company called Light Logics in Trivandrum. And they are pioneers in holographic technology. Holograms that you see in the credit cards and security systems. Dr. Ajit, he's in 1980s Cochin University PhD. He runs that company there. Twice Lockheed Martin gold medal for global innovation. Nobody knows. Such a lab is there and such things are being developed right here in Trivandrum. So there is also an information problem. When we hear such things, we are inspired to try something like that. Right? Like Logics. Please look up their website. And he was there in college 2 weeks ago and he was saying, we are not making any lasers in India. We are still importing such stuff. But we are really good now at launch vehicles. So this shouldn't be a problem. A country that makes launch vehicles for soldering iron can't be a problem. We should be able to make. But can we guide the spirit in that direction? Yeah.
Any more questions?
Suppose we manage some goals and we not take this thing. So suppose if we start really early, so we need to be specific. Suppose from this BTech only, we cannot be that much specific.
Right.
So how should we take up that challenge? We can't be specific such that just develop this product. Maybe at some time you want to find we have some seminar on the people from different startups who are there and they will college students itself.
Right.
I like that much, but there's one problem with that. They are not so mature to sustain that to a that level. They have started very early, but it seems like they are such a great person. They have experimented well and they have very great contacts. So how should we take up to that problem? Rather than being specific, we should be a part of this great innovation in India itself. So what are your views on that?
Yeah, see, let me plug something in there. I wrote a very small book called The Startup Habit. Right? It's available in Amazon. I'm the co-author with Dr. K.C. Nayak. The reason why we called it as a habit is because this thing needs to become second nature, how to innovate in startup. The only way of doing that is to develop a very good relationship with failure. We are going to try something and fail. And fail again. How to keep doing that? This training doesn't come from conventional methods. The very successful young entrepreneurs that you find, whom the media will focus on, are the guys who got it right in the first time. But that's sheer luck. Most of the sustained innovators are people who had 2 companies, 3 companies, they all went bankrupt. Look at Donald Trump, right? President of the United States, so many bankruptcies. Every time he files a bankruptcy, he becomes richer. Look at the history of it. So that's a relationship which we need to cultivate. So for that, you need to start right from maybe first year or second year. You have an idea, you try to make that into a product or a service, take it to the market, at least have a market among your friends, see what the feedback is, adjust accordingly. Maybe it will bomb, nobody will like it. Then what did I go wrong? Each of this is an experience, it's an experiment. That will benefit you. Right? The team that runs the startup village in Kochi, the guys who founded it, their first company was called MobMe in Trivandrum. They came from College of Engineering, Trivandrum. They are all, if you look at them, they look like a proper team because they were a proper team. They were part of the CET basketball team. All of them are 6 feet tall. They are all saints. So, but they wanted to do something on their own. So the first business they did was they needed money to go and attend all these basketball matches around Kerala and South India. So they used to get T-shirts from Tirupur at a very cheap rate. And they used to resupply that to hostels in CET. That was their first money-making business. Now, we all know that T-shirts have a long life in college. So there is no recycling business. So the market was dull at the end of 1 year. Okay, last year why would I buy again? I still have it. So then they switched very timely into SIM cards. So that's how they got into the mobile domain. And then you can read the interviews with Sanjeev Dhurandhar where it is. We were negotiating for a server space and server when nobody had any idea what a server meant. So that's part of the deal where you learn as you go along. But you keep up that spirit of this can be done. How clear I am about feedback. How can I review my decisions and so on. So it's a habitual thing that you will do. 95% of business will fail. So we need to get clear about that. This is the exact opposite of our academic success rate. Yeah, 95% pass in SLC exam, 95% of business will fail. So we need a state that will collaborate with this. Okay.
Any more questions?
Yes.
Like that curriculum that you were telling, like we generally blame a curriculum kind of thing. What I felt like, if there is some given free time to a person, he can himself figure it out, like what he want to do.
Yes.
If given some mentors are there in the environment, like that's the one thing that should be implemented.
Yes.
It's not blaming our curriculum.
Exactly.
It's very fine. It's okay.
Yes.
That is kind of a constraint thing that we have to do.
Yeah, the method of delivery is the problem. How it is delivered.
That's the problem. But like as much as free time is there now, that person can develop himself on his own. No faculty can guide, no faculty can deliver that kind of innovation to him.
Yes.
So that should somehow manage to be able to implement it in the curriculum.
Yeah, actually, what has happened in the last 5 to 10 years, earlier there was only theoretical theory. So at least, okay, if you do that theory, but at least you have the theory. But now what has happened is class project, assignment,
everything is structured now. Too much of structure.
So that has happened.
Yes. See, the same guy, Nakhoff, who said, the only people benefiting from education is teachers. He also said, you start learning the moment you stop school. The moment you get out of college, your real learning begins. This is unfortunately true. But see, that point about free time and having a personal decision, there is this new school called Trivandrum here in Trivandrum. They have a very interesting curriculum where for 5 years till 8th standard, these kids are just asked to do 50 projects. That's all. And that school has no classroom. They only have corners. Ramanujam corner where mathematics is taught, Malayalam corner where Malayalam teacher is sitting. So all these faculty members are available at the different corners. And the faculty will put up a schedule about how his day is going to be. 9 o'clock to 10 o'clock, I'll teach addition. These are second standard upwards, right? 12 to 11 division, and Sanskrit one corner. 8:30 in the morning, all these students come. They are running around looking at each of the corner about where they should go and sit, according to their interest. And they'll ask the faculty, will it be useful for me if I come here and this thing? And then, useful in the sense they are doing their project. That is their priority area. These 4th standard kids come to our college for robotics help. And they come asking questions which BTech students are not asking. Actuator size, and very specific information about battery, what that can be used. It's fascinating because they search everything on Google. because they are very keen on doing this, and these kids don't mind coming on Sunday, Saturday, holiday, because it doesn't feel like a farm. It feels like a whole hunter-gatherer thing where they're running around getting information. Plus, structured classes, whenever they want to sit, they'll go and sit. Makes a big change. And then, so such alternate schools do exist, where learning is in a different platform altogether. But I think by undergrad, we did have a lot of free time. My BTech time, I remember, most of the afternoons were free. Or I'm not very sure if I made them free or they were actually free. most of the afternoons were free. You know, because I am a morning person, so I like the 8 o'clock, 8:30 lectures. I'll go very promptly for them. So maybe could have given the illusion to the faculty that I'm a very regular guy who comes. Only few people come at 8 o'clock, so these guys are there. But free time, really, that's when you get me. At least after you are 18 or something. Very important. Right.
Any more questions?
Okay, thank you so much.
So thank you so much for that wonderful lecture. We would like Dr. Umesh sir, the faculty coordinator for Conscientia, to present it.
Thank you so much.
Thank you so much.